Okay, next we're gonna talk about we already talked about the physical properties of alcohol. Now we'll talk about the chemical properties of alcohol and carboxylic acid and the formation of ester or esterification. So the first thing is we have to know how is alcohol prepared. And normally we use ethanol. Methanol is too basic. So we use ethanol more. So there are two main ways to prepare ethanol. Number one is hydration of ethene. Like we already learned hydration in the last video. Need to have H3PO4 as your catalyst, phosphoric acid, as well as 300 degrees Celsius and 60 atmospheric pressure, and react with water or steam. But there's another way, which is fermentation of glucose. So fermentation of glucose is the glucose is what's it called again? Decomposed by zymase enzyme. So zymase is an enzyme that acts like a catalyst, and it changes glucose into ethanol and carbon dioxide. So you normally see this in yeast, you normally see this in yeast. Like the reason why the yeast punya dough becomes like very fluffy, like it expands, is because of this carbon dioxide gas. It pushes out the yeast. Okay, let me see what else it mentioned. I don't know if it mentioned anything about reflux. I remember there is one. Okay, your goal is to try and find any reactions that require reflux, because I forgot which one is reflux. So yeah, if after this I'm going to go and look at my other book and see if I can find the reflux reaction there. So first of all, the first chemical property of alcohol will be combustion of alcohol, which I already talked about combustion. Remember, I said in that video, you have to take note of this oxygen here. Your total oxygen here has to be equal to the total oxygen here. So you have to make sure it's balanced. So like, for example, in this one, there's two carbon atoms. So you have 2 carbon dioxide. So you have 4 oxygen here. And then 5 and 1, so you have 6 hydrogen. So it's 3H2O. So you have 7 oxygen. But one of your oxygen comes from here. So you have 6 left. So 6 divided by 2 is 3. Next is oxidation of alcohol. So what you do is you add alcohol, or usually it's ethanol, and you add it with an oxidizing agent. It can either be KMnO4 or K2CR2O7. So it's either potassium manganate 7 or potassium dichromate 6 solution. And then you have to remember the changes of color lah. So for example, as I said in the last video, potassium manganate changes from purple to colorless, while potassium dichromate 6 solution, acidified by the way, it has to be acidified. Acidified potassium dichromate 6 solution turns from orange to green. So yeah, and your alcohol, normally it's ethanol, will turn into water plus ethanoic acid. Okay, the other reaction is dehydration of alcohol. I think this is the reflux one. Wait, no. I think it's the esterification one. I forgot which one it was. Yeah, again, I'll just look at it again later. The catalyst for dehydration is porcelain chips, or it can also be alumina. Aluminum oxide and alumina is the same, or concentrated sulfuric acid. But if concentrated sulfuric acid, there is like an extra condition. I forgot the condition. It's in my book, however. So, I mean, it's in the focus book that I bought. Let me see if I can find it. Because I remember writing up something over there, like talking about how bad the textbook is, because the textbook is actually kind of bad. I mean, it's okay, but yeah. Compound. Where is it? Give me a bit. Looking at the book again. Oh, here. It's either passed through a heated catalyst, or if it's under sulfuric acid, it has to be heated under reflux. Okay, there's other reflux reactions. I'll talk more about that later. Next is dehydration of ethanol. So you heat up the ethanol, and then you will get ethene. So basically, these two become steam, and then these two form double bonds. So it's basically the terbalik lah of the first reaction. I forgot what the first reaction was. I think it was phosphoric acid and 60 atm, 300 degrees Celsius. Okay, alkene has the following characteristics. Yeah, burns with little sooty flame. This one I'll talk about later. Not later, in the next video, because there's a question regarding it, sootiness. Decolorizes the brown water of bromine water to colorless. So that one is halogenation. And decolorizes the purple color of KMNO4 to colorless. This one is oxidation. Okay, so this one is not that important. Okay, carboxylic acids. So carboxylic acids is, as we know earlier, produced from oxidation of alcohol. So there are two main reactions of carboxylic acids: reaction as an acid and reaction as with alcohol. So reactions with an acid as an acid. We learned in junior 3 like a lot of types of reactions. Like for example, acid plus base is salt and water. Acid plus base is salt and water, or acid plus salt. In this case, it's metal carbonate. Is salt and what's it again? Salt and it was acid plus salt is acid and salt. But since if it's acid and carbonate, you produce what's it called again? Carbonic acid. So carbonic acid is very unstable, as we remember in junior 3. So what happens is carbonic acid will decompose into water and carbon dioxide. After that is carboxylic acid and metal produces salt and hydrogen. So these are all like last time in chapters. So yeah, and then if you remember correctly, ethanoic acid is like in chapter 2. It is not chapter 2, form 4, senior 1. It is a weak acid. So it is a very, what's it called again? I forgot what's the name of the weak acid. But basically, it can convert in water. It will ionize to become ethanoic ion and hydrogen ion. But it can easily turn back into ethanoic acid because it's a weak acid. However, it still undergoes these reactions. Next is reaction of alcohol. So reaction of alcohol is one of the most important parts of this chapter because the chapter likes talking about ester. So what happens is you need to react with concentrated sulfuric acid. I think under reflux. Yeah, I'm gonna go back and look at what my book says. But basically, you react with sulfuric acid and concentrated sulfuric acid, and you will produce ester and water. So this reaction is called esterification, with the presence of concentrated sulfuric acid as the catalyst. So the most confusing thing is how do you name it? Okay, so first of all, this thing on the left is carboxylic acid, and this thing on the right is alcohol. So this is carboxylic acid, this is alcohol. But when you name it as alcohol first and then carboxylic acid. So for example, let's say you have ethanoic acid. Yeah, if you have ethanoic acid and ethanol. Wait, I think I mentioned it as ethanoic acid. Wait, yeah. If you have ethanoic acid and ethanol, and you react them together, then you will get ethyl ethanoate. But you'll get ethyl ethanoate. So you see that ethyl here comes from ethanol, and ethanoate here comes from ethanoic acid. So the reason why it's called ethyl is, the alkyl group, the branch, this turns into a branch. That's what I understand. So that's why it changes from alcohol to alkyl, because it becomes a branch. But that's not worth knowing about. So just know that when you write down carboxylic acid plus alcohol, write alcohol first, but the alcohol is YL. And then ethanoate. So from oic to OAte. So yeah, so let's say you have ethanoic acid and methanol. No, methanoic acid and ethanol. So you will get ethyl methanoate and so on. Okay, let me see. Okay, so there is a very, very, very important characteristic about ester. Ester is what we call fruity. It smells very fruity. Mainly ethyl ethanoate has a fruity smell. So yeah, it smells very fruity. It can smell like pineapple. It can smell like apple. For pineapple is ethyl butanoate apparently, and apple is methyl butanoate. So yeah, this is what I mentioned earlier. Um, the left part is carboxylic acid, and the right part is alcohol. But when you name it, the first part that comes out is the alcohol, and it becomes alkyl, while the second part is the carboxylic acid, but it becomes OAte. Okay, so yeah, this is the physical properties of ester. One of the questions mentioned that it is less dense than water. It is colorless. It can easily vaporize, and it is sweet and fruity. And it is insoluble in water. Ester is insoluble in water. Okay, I already mentioned about isomers, so I think we're done with the chapter. I guess now, okay, yeah, this is more of the uses of stuff. I don't think it's worth teaching. It's something that you can just read. So like yeah, alcohol beverage, fuel, you can use it's flammable, so you can use it for power, energy, and ester can become like flavoring. You know, flavoring, food flavor, food coloring. Yeah, it comes from ester. So yeah, that's why sometimes you can make your icing taste like apple. That's all from me. Now next